Assalamualaikum warahmatullahi wabarakatuh. We are from group 13 and the member is Denissa Nurul and me Syifa Nuriyah. We will explain about graph in mathematics for biology. For the first is translate information between graphical, numerical and algebraic forms. Here there are some explanation about translate information between graphical, numerical, and algebraic forms. Okay, for the first is drawing a graph. Drawing a graph is translate from numerical to graphical. And the second is reading data from a graph. Reading data from a graph is translate from graphical to numerical, and the last is translate from graphical to algebraic and back. Okay, the next in mathematical concept, there are three general graphs. Consist of a graph with a horizontal straight line, and then a graph with a non-horizontal straight line, and the last a curved graph. For the first is a graph showing a horizontal line parallel to the x-axis so that the variable plotted on the y-axis is independent of the variable plotted on the x-axis. In mathematical terms, this relationship can be expressed as y equal to x to the power of 0 or y is constant, where the constant in question is given by the y-axis value of any point on the line. The second is a non-horizontal straight line. A non-horizontal straight line so that the variable plotted on the y-axis is proportional to the variable plotted on the x-axis. And in mathematical terms, this graph can be expressed as y equal to m times x plus c, where m is the gradient of the graph and c is the value of the intercept on the y-axis. And the last is a curved graph. A curved graph that passes through the origin indicates that the variable plotted on the y-axis is proportional to a power of the variable plotted on the x-axis that is greater than 1, or y equal to x to the power of n, where n greater than 1. The next is context in biology. A key feature of any line graph displaying a relationship between two variables is that the gradient of the curves represents the rate at which the quantity of the y-axis is increasing as the quantity on the x-axis increasing. For example, when describing the features of the myoglobin curves, we could describe the step gradient in the middle part of the curve by saying, at PO2 between 1 and 3 kPa, the percentage saturation of hemoglobin increases rapidly as PO2 increases. For the next is plot two variables from experimental or other data. In mathematical concepts, there are several rules of plotting a graph. That is, 1. Points plotted must be within 1 square of the correct value. 2. Appropriate linear scale used on axes. 3. Graph should make good use of available space. 4. Scale should be sensible, that is, using decimal or otherwise straightforward scale. The next, scales must be chosen so that all points fall within the graph area. That is to say, point must not be plotted outside the graph area. And then, axes must be labeled with unit include. And the last, there should be an informative title. And the next is context in biology. For the first, there are rate of reaction. There are the data, and usually data provided in a table. And then that is the graph, and for this graph, sensible scales would be for the x-axis is 0 until 11 minutes with 1 minute per measure square. And for y-axis, we have 0 until 110 millimole per decimeter cubic with 10 millimole per decimeter cubic per measure square. The next is calibration curves. A calibration curve is a technique whereby a relationship is established between two variables, so that the resultant curves can be used to establish a property of an unknown sample. For examples, in colorimetry, a calibration curve is used to establish the relationship between the absorption of a particular wavelength of light by a solution and the concentration of a color solute. And in the table is data might be produced for the absorption of a reducing sugar of known concentration tested with Benedict region. And we have suitable axis scales would be for the x-axis we have 0 until 1.0 mole per decimeter cubic with 0.1 mole per decimeter cubic per square. And for the y-axis, we have 0 until 1.0 absorbance or arbitrary units with 0.05 arbitrary units per square. In the graph, the calibration curve is then used to determine the concentration of an unknown solution of reducing sugar. If such a solution has an absorbance of 0.56, the concentration according to the line of best fit is 0.70 mole per decimeter cubic. And the next we are presenting by Denissa.
So now I will present about understand that y equal to mx plus c represent a linear relationship. In mathematical concept, this concept is a two-way process as discussed in before material. We should be able to work out a linear relationship given a graph and be able to sketch a graph given a linear relationship. a non-horizontal straight line show that the variable plotted on the y-axis is proportional to the variable plotted on the x-axis. In the mathematical terms, this graph can be expressed as y equal to mx plus c. M is the gradient of the graph and c is the value of the intercept on the y-axis. Sorry. In biology concept, a graph of a rate of reaction against a threat concentration for an enzyme is displayed below. This is the example of intercept on the y-axis represented by c. This is c. In the equation is 0. Therefore, in this case, the equation becomes y equal to mx plus 0 or y equal to mx y equal to mx plus 0 equal to y equal to mx. Next is about determining the intercept of a graph a level only. In mathematical concept, finding the y-intercept should be expressed but be self-explanatory. We should examine where the line crosses the y-axis and this value is the y-intercept. This is where x equal to 0 for the x-intercept. It is where the graph crosses the x-axis and is where y equal to 0. Context in biology. In biology, we should maybe ask for the y-intercept in contexts such as osmosis. At a level, we could be asked for the intersection of two series of data, for example, composition point in plant. The composition point, or L, are where the rate carbohydrate production from photosynthesis and the rate of carbohydrate used by respiration are equal. So next is about calculate rate of change from a graph showing a linear relationship. In mathematical concept, we find the gradient. The following formula is useful if m equal to change in y divided into change in x. For example, we are studying transpiration. We take reading of the total volume of water loss. As time passes, when we plot this result as a line graph, the gradient of the line gives us the rate of transpiration. The gradient can be calculated by the gradient formula. Rate equal to gradient. Change in y divided into change in y. This is. Okay, next is about draw and use the slope of a tangent to a curve as a measure of rate of change. First one is use a ruler and pencil. This sounds obvious, but many learners will not do this naturally. The second one is line the ruler up to the point where the tangent is supposed to be taken. The third one is while aligning the ruler, make sure that in the vicinity of the point, none of the line of the curve is covered by the ruler. So the concept in biology is to find the rate of reaction at 2 minutes, a tangent has to be drawn to approximate the gradient which present the rate at that given time. The gradient of the tangent is calculated as described in section before by dividing the change in y by the change in x between 2 points. For example, between the 2 points 1,33 and 3 80. On the tangent above which given gradients 47 divided into 2.3 is 20.4. So the rate of direction at 2 minutes is 20.4 mole dm cubic min subtract min 1.
Maybe that's all from me and Denissa. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.